Good afternoon. Thanks for being here. I would like to introduce you to Mateo Alvarez, data scientist at Stratio. My name is Raul de la Fuente. My role is Big Data Pre-Sales. And we are going to talk about shipping machine learning to production. First and foremost, we are happy to share our presentation. If you want to scan the ID or write the address on your mobile, you can follow the presentation and download it. It works? OK. Generally speaking, we all share the same goal. Companies share the same goal. And our goal is to increase profit. It's essential to reduce the time to market. It's essential to keep up with the competition. And that is the we are going to talk about. The machine learning cycle. A general overview. Yes, everything starts with a question, a business question. After that, we need to study the problem in order to identify different decisions, different ideas, in order to identify the data sources. After that, we need to build a model by training with the data source. And after, we need to iterate over and over again in order to evolve the model. Once you find an appropriate model, you deploy it. Keep in mind the data is in the middle of this cycle. Okay? If you thought you were here to rest, you are coming here to rest, you are totally wrong. You are going to work here. So would you mind to answer this question? What do you think? Most of you think there is one. Oh. You are a lot of challenge here. Yeah. Deploy a model and train a model, the winners. Okay. In fact, there is no a right answer, because every company needs to prioritize the phase of this cycle. But another question: what is the name of this animal? What is the name? Hippopotamus. Everyone knows that, right? But maybe you don't know this word. The origin of this word is from Greek. It's a Greek word. Let's imagine for a moment, it's funny. Let's imagine a Greek person walking around and they suddenly found this animal for the first time. And maybe thought, what a strange animal. What a strange horse. Maybe the driver has something to do with it, because hippopotamus comes from hypo, that means horse, and potamus means river. It seems the humans have the inherent ability to transfer knowledge with this task. It's easier to combine different terms than make up a new word. And often, the machine learning algorithms are inspired by human learning. And what is the main point to human learning have? The first one is to learn from examples. But the most of the algorithm, the traditional algorithm, you need to write explicit rules. That's in words. The second one is to retain, learn knowledge. For this reason, it's important to have a good repository. And finally, reusable in other tasks. In contrast, most of algorithms are focused in isolated tasks. So you remember the cycle, the last few years, new algorithm, new analytics platform, new libraries, frameworks has been developed. All of them around the data. But what if, in addition to the data, we take full or partial advantage of the previous training in order to solve the current problem? From what I can gather, the data itself is vital, but the knowledge is king. The knowledge is, well, machine learning usually is very good to recognize patterns within an error domain. Here, it's totally bounded to the source domain, but the knowledge is not static. Clearly, it's not static. So we need to be aware of that. Remember, we want to keep up with the competition. What happened with our algorithm in order when new data sources pop up over and over again? So we have some limitations. The first one is data hungry. Maybe your organization can afford to collecting large data sets to train your machine learning algorithm. Secondly, compute price. Computer price are expensive. Particularly in deep learning, you need to access to GPUs, to hundreds of gigabytes in your GPUs. It's not cheap. And finally, you need people who really know what they're doing because of setting up the hyperparameters. It's very difficult, very hard, believe me. So transfer learning try to face this limitation in some way. And the concept is easy. You have one knowledge, like in hippopotamus, you have different data, and you need to solve a problem, a target task. In this way is the right shape. And you have the knowledge of the different triangles and squares with different colors. We learn from examples. For this reason, I'm going to show you with an example. Let's imagine we need to build a model, a security model. And this model needs to understand different tough situations. The situation is like a fire. Okay? You have two choices. The first one, you can learn about the effects of fire by burning down your office. It's crazy, that nuts. Or you can use the transfer knowledge of the transfer style of the fire and your office. Okay? Because here we have several stuff like the wall, the table, the window, and so some of them share the same Fs, the same shapes, the same colors, and we really know what is the encode in the convolutional neural network in order to understand these features. So the result would be something like that, okay? And you are able to train your model with a data set in this way. It's important to understand we have different ways to carry out these problems because it's not the same similar domain with different places and different domains with the same task. So in order to carry out this problem, we have different methods. The first one, in order to summarize, fine-tuning is freezing some layers of your network. The second one is multitasking. We have seen a very graphical model, graphical sample, but maybe the span classification is the same, because you can reuse part of this span classification in another totally different task. And domain adaptation is one of my favorites. You are able to move some concepts of one domain in another domain. And zero suit is is when you add some attributes in your neural network. However, it looks pretty awesome, but you shouldn't imagine that like a Matrix movie. It's in fact actually like was on, was off. You reuse part of your knowledge to accomplish another totally different task. So the impact. Remember, we want to ship faster. The initial performance here will be better. And the amount of data you need to train your machine learning algorithm will be lower. And the amount of time to find an appropriate model will be lower as well. So you can reduce the time to market. I have no doubt the next generation of analytic platform will be something like that. Ensemble different models in order to not only to improve the performance, but also to combine the knowledge in different tasks in another totally different task. In addition to this, you can deploy, is another phase, as quickly as possible. And Mateo is going to deep into in this subject.
Okay, so no, we keep with the presentation. Hey, can you put the presentation, please? Okay, so we've been talking about a little bit about this machine learning cycle and the most painful parts of it. Most of you thought that training and deploying the model were the most complex tasks. Indeed, we think that's the same. We've been talking about a little bit about how to increase the speed in training the algorithms and how to reuse this knowledge for other tasks. And then we are, so I blocked the phone. No, okay. And now we are going to talk about deploying the algorithm in a really fast way, okay? So by now, the way usually we deploy models is we train some model with different technologies. So for example, TensorFlow or scikit-learn or Spark, these among many others that you could use. And what we do now is when we want to offer an API, a service to a client, we build a backend specifically for each technology. So when we have different technologies, different models trained in different technologies, we have to build different backends from each application. Okay, so why building different backends? Why making APIs from the models? That's because when you train a model, the amount of resources you need is usually high, as you have to train the model with lots of examples, and you may need, for example, Spark, because you want to try to parallelize the data and the training. And so you generate a Spark algorithm, and then you build a microservice with the model trained as the requirements to provide the service to the users are really different. So what we did at Stratio is using this technology, CombustML, which provides a way of generalizing these training models in different technologies to build the same kind of API. Okay, so it uses Java. You can train the models in one of these technologies that they are supported in this technology. And then you can deploy the model in a microservice with an API and provide the users with predictions. Okay, our implementation of that is because we want to provide the users with this data-centric approach. We have this strategy intelligence. The first part would be the application to train the model, to do the data science, to build the pipelines. Then we can save those models into this model repository. Okay, so then when you have your model trained and it's ready to go to production, you can save the model with this repository, and you can even keep different versions of each model. So you can reuse, as we spoke before, the knowledge in different tasks. And the last part would be you can interact with this model repository to deploy microservices within the platform. You can have this API with the model. Okay. All of this runs inside the Stratio platform. I'm going to show you now a little demo on a development environment. So please pray for me. As you know, it usually works, okay, but with the demo effect. So you can change to the no. Can you change to the okay, to my laptop? Okay, so this is Stratio platform. Maybe some of you have seen it. We have these services, all the applications running within the cluster. We have this intelligence folder with all the intelligence applications. We're going to see what a data scientist would see. So we have this Jupyter Notebook adaptation to run with Spark and other technologies. And what we did here is to plug this application with the model repository. So when we create the model, we can save it. By now, we use HDFS, but any other solutions can be also used. So we check the connectivity with the repository. OK, so it's working right now. I'm going to go through this really fast. So we may have this sample model. This is from Airbnb. We are trying to predict the price of the houses regarding some features. OK, we did the training. I'm not going to run this, as it can take some time. The interesting part is here. We have developed these functions. We can save the model. We can delete the model. Okay, not only the model, but also a pipeline built in Spark, for example. So, okay, I have this model already trained. I'm gonna save it. Okay, so it says this is what connection with the model repository says. It was uploaded correctly. We can list there the models available. Right now we have a separate interface to deal with this model repository, and then we know, okay, everything works. Okay, but I had this model already deployed. With this command, you can at least deploy the model from this interface, and then you have these microservices up and running to answer the client's requests. So that's the demo. If you can put the presentation back again, please. Thank you. No. Okay, so
Yep.
this is the end of the presentation. Thank you for coming.
Yeah.
If you have any question, please feel free to ask. Okay, no questions.
No questions. It's about the repository, about the deploy, about the transfer learning, about the other
Architecture,
mechanisms.
anything. Okay, anyway, we are over there at the stand.
Yeah.
If you guys want to come later to ask anything, that's all.